All right, function notation. So this is kind of 8.5 function notation. All right. An equation, y equals 2x plus 7. What kind of equation is that? What form? Slope-intercept form. It's the same slope-intercept form you've used since 7th grade. It's not changed any. The difference in what we're doing today and that stuff is that we're going to use function notation. So instead of y, we're going to write f of x. X is the input, and f of x is the output. X is the input, y is the output. Y and f of x or g of x or whatever letter they use is the same thing. They're the same thing. Okay? Function notation just gives us a little bit more information about things. Okay? So the example that they use there is they say function notation is especially useful for finding the range that corresponds to a certain domain value. Finding the y value that goes with an x value is what they mean. Okay? So the function is f of x equals 2x plus 7. They want us to find f of negative 3. That's how you say that. F of negative 3 is what they want us to find. All that means you do is put the negative 3 in the place of what? X. You guys have seen this before. It should not be anything completely out of left field. You may not remember as much about it as I would hope you would, but it's not anything you can't pick up real quick. Okay? Now all we got to do is work out the right-hand side. That'd be negative 6 plus 7, which is 1. So f of negative 3 is equal to 1. You're not trying to solve for f. You're trying to work that out and get the y value that goes with that x. What this function notation is another way of writing the ordered pair negative 3, 1. That's what that means. The ordered pair negative 3 is x, 1 is y. That's all function notation is. It just means, hey, when this x is negative 3, the y value is 1, it came from a function. So it was something that passed the vertical line test. It's something that has some properties to it. Okay? So really easy thing. Let's do a few examples. We won't do all of these down through here. We'll just do some. Let's do, they give us the functions f of x is equal to negative 5x minus 14, and g of x negative x squared plus 9x minus 1. And we want to work out some problems. So I'm going to do number 1. And it's asked us to do f of negative 9. Which one of those do I plug into? The f of x function. That's what you mean. You're trying to say use this one to do number 1. That's correct. Okay, so we're going to plug in negative 9. It's negative 5, parentheses, negative 9. I advise you get in the habit of when you plug in a number for x, put it in parentheses. That's going to help you, especially when we get to the ones later on down the page when you're plugging in a fraction. Put it in parentheses x. Okay. I can do that without a calculator. I advise you to try to do as much as you can without one. Don't rely on it for the easiest things, but that doesn't mean you can't check it with the calculator. Okay. So that would be 45 minus 14, which is 31. F of negative 9 is equal to 31. That would be your answer there. Oh, yes, can you turn that here on? No, you don't have to put the ordered pair. When I was saying up here with it, that's what it means is an ordered pair. You don't have to write it as an ordered pair. This function notation, this is technically writing it as an ordered pair like that. Means the same thing. Okay? Let's do number 2 because it's got a fraction in it. Everybody loves fractions. So f of 3/10 means put 3/10 in where? the x's in the f of x function. So be negative 15 over 10, which reduces to be negative 3 over 2. And use the calculator to do that. Negative 3 over 2. I'm just using the division symbol, minus 14. And then hit math, enter. And that'll convert it to a fraction. So negative 31 over 2. So f of 3 over 10. With that graphing calculator, if you're using a TI-84, you can use the fraction buttons to do that. You could say negative 5, parentheses, and then alpha y equals. It gets you the fraction 3 over 10. Oops. Delete. Press the right arrow key, parentheses, minus 14. And it saves you the step of having to convert it back to a fraction. If you're using the 83, it won't do it that way. It doesn't have that capability. It doesn't have enough memory to do that. The 84s do. Okay. And if you've got an 84 that you purchased and it doesn't do those things, let me know. We'll update it to the newest operating system and make it work if you've got an 84 that you borrowed or purchased from somebody. Okay. Skip down there to number 4. It asks us to do g of negative 7. And the g of x function, remember, is up there at the top, negative x squared minus 9x, or being plus 9 times x, minus 1. I know that that's going to be negative 49 minus 63 minus 1. So negative 50 and negative 63 would be negative 113. Again, you can use a calculator to help you get that ordered pair. Be careful right there on the negative in the parentheses. Be careful, because if you on your calculator, if you're typing that in, your graphing calculator, if you just type negative 7 and then hit squared, it gets you negative 49. But if you meant to square negative 7, like we're doing in this problem, what happens every time you square a number? The answer should be what? Positive, always. So your calculator doesn't read it the way that you meant it to do. It reads it as negative, then 7 squared, which is following order operations to the T. So you've got to do parentheses. So if I put parentheses negative 7 squared, it gives me back the right thing, because then you are squaring negative 7. The calculator is very picky about that. If you used to use the little TI 36 or 30XAs or 30X2s, like we've got, I think you've got one on your desk like that, it does the same thing. Like the dark blue ones, they did it the same way as the graphing, which is why I like them better, because you get used to that style. Okay, be careful of that. Let's jump down there to number 5. And it asks us to find f of 1 minus f of negative 4. So it's adding an extra step. When I talk about ACT a lot, because that's something you're going to have to do, and Algebra 2 relates to a lot of the math on the ACT math test. This would be a problem that would be on the second half of the ACT math test. The first half is the easy problems, 1 through 30. You get to 30 through 60, those are the harder problems. They usually are the same kind of work as the first half, but there's an extra step. So this one, find the function values, and the extra step is subtract the answers. So we're going to find f of 1 So that'd be negative 5 times 1 minus 14. And then we're going to find f of 4, or excuse me, f of negative 4 is what it asks for. So that'd be negative 5 times negative 4 minus 14. We're going to find both of those answers. So that'd be negative 5 minus 14, which would be negative 19. And then when we find negative 4, that'd be 20 minus 14, which is 6. This problem would be negative 19 minus 6. Negative 25 would be the final answer to that. So be careful of that, that you're finding those two values first and then doing the work. Number 6, right there, we'll do that one. 2 times g of 12. Yeah, so we're going to find g of 12 and then double it. Yeah, that's exactly right. So g of 12 would be negative 12 squared plus 9 times 12 minus 1. So that'd be negative 144 plus 108 minus 1. Negative 145 plus 108. Negative 144 plus 108 minus 1. Good. Negative 37. And then I'm going to say 2 times g of 12 means 2 times negative 37, which is negative 74. What's wrong with my 4 there? It wouldn't work. The final answer would be negative 74. Not terrible. Not too bad stuff. Let's do number 7. Bunch of fractions in there. You need to practice doing fractions. P of negative 9 over 16. The P of x in the problem above, the instruction says 1/2 minus 4/3 x. So we're going to plug in negative 9 over 16 everywhere there's an x. So we got 1/2 minus 4/3 is negative 9 over 16. You could do that with a calculator, but you don't have to have a calculator to do it. I'm going to do it without it. 4 goes into itself once, and into 16 4 times. 3 into itself once, into 9 negative 3 times. So that's going to be 1/2 plus 3/4. Turns to a plus because we had a negative times a negative. This is a minus sign on the 4/3. And then we're going to add those together. I know 1/2 is 2/4. 2/4 and 3/4 would be 5/4. If you force yourself to do things without the calculator, you will get better at doing them if you make yourself do it enough. Okay, so try to force yourself to pursue things without the calculator. Not saying you can't check yourself with the calculator. Just try to make yourself. That will speed you up when it comes to ACT math time. If you can get through the first 30 questions in 25 minutes, those are the easy ones. That gives you 35 minutes to do the last 30 questions.
Jack Whitley, Gracie Brown, please report to office.
Okay. All right, so number 9, skipping right down to it, it's q of negative 2. And the q of x function up in the instructions was absolute value of 3x minus x to the 3rd power. So I'm definitely going to use the calculator to help me do the 3rd power stuff. Usually that's a little larger. I think I could do this without it, but I want to make sure. So I'm doing absolute value of 3 times negative 2 minus negative 2 to the third power. Again, I'm putting it in parentheses because I know that negatives and exponents can get a little crazy sometimes. So I put it in parentheses. I'm going to type it into the calculator as 3 parentheses negative 2 minus parentheses negative 2. And then to get the third power with the graphing calculator, over here right above the division symbol is the caret symbol. That's an exponent. So when I hit that button, it puts me to an exponent, and I need a 3. And I'm just going to hit enter, and it works that out to be 2. So absolute value of 2. What's the absolute value of 2? 2. And there we're done. Easy stuff. All right. Let's skip on over to the next page and look at number 13. F of x, 3x plus 19. And they want us to find if f of x equals 34, find x. How?
Soccer team needs to be dismissed at this time. Thank you.
I'll post the video. 34 equals 3x plus 19 and solve it. Yes. We're not going to get to the second mechanism today. So we'll do that.
Caitlin Miles reports to office.
Okay. All right. So, set 3x plus 19 equal to 34. Solve it. No. If you wrote the 34 first, equals, that's fine. It does the same thing. So 3x, 34 minus 19 would be the same as 35 minus 20, which is 15. Yeah. So they teach that in elementary school now. I don't know if they taught it when you were there. Probably not. That's a new thing. It's that Common Core math. Part of the new way of getting people to do more math mentally and less on the calculator. That's the idea. Okay? So anytime they ask us to find that, we're just setting it up and solving. 14 is the same thing. We don't have to do that one. All right, let's look at a word problem. Okay? Number 15 is a word problem. Owen paid a landscaping company $108 for an initial lawn treatment, then $74 per month thereafter. The function P of t equals 108 plus 74t represents the total amount of money he will have paid after t months. A part says take that stuff and find P of 24. Is that any different than what we've been doing? No, it's just tied into a word problem. So what the point of this is, don't freak out because it's a word problem. It's the same thing we've been doing. It's just buried within some words. Okay, so we're going to set up P of 24 is equal to 108 plus 74 times 24. These are bigger numbers. I'm probably not going to be able to do. I could, but I'm not going to. 74 times 24. 70 times 20 would be 140. And 28, so it'd be 168. And then 4 times 24 would be 96. And add those together, or just do this. 74 times 24. It'd be 1776 already. And then add that together, 1884. Guys, I'm not kidding you. If you'll do more without your calculator, you'll be able to do numbers like that in your head. When I first started teaching, I wasn't as good at numbers in my head as I am now because I'd gotten so used to using a calculator so much. And then I just got tired of it, and I said, I'm going to make myself do it. So I quit using the calculator to do numbers. This is 14th year. So just takes time. Within a couple of years, I was about where I'm at now. I just had never. Once you get to a certain level, you don't get any better. So, all right. So that's A part. B part of that same problem says, yeah, I know. All right. So B part of that same problem asks us to then do a little bit of different work, maybe. It says how long has it's supposed to be has Owen been receiving loan service if he's paid a total of $2,994 to date? What is that? What problem is that like that we've done already? Isn't it like 13? You're taking the equation and setting it equal. So 108 plus 74 or t is equal to 2994, and solving that. That's all that means. It's buried in a word problem, so it makes it feel complicated, but it's the same thing we've been doing. No different math. No new math. There's no such thing as new math. Don't let anybody tell you that there is. Math's been the same for a couple hundred years. So 8, 14, 6, 8, 8, 2. And then divide that by not 100. You get 2886 when you subtracted 108. 2886. I got 39. Is that what you got, okay? Good. 39. Find your mistake. It's probably something small. Subtract 108. Divide that by 74. Oh, yeah, that messed you up. Be careful about that. All right, so word problems don't get that complicated. They're really actually not too bad. All right, let's look at a couple of them from 16 through 20. Okay, let's do 16 and 19. Let's just do those two and we'll be done. That'll be it for today. We're not going to get to that second pack of notes. I was a little ambitious, thinking that I would. All right, so 16 is using the f of x function, which is negative 4x plus 9. What are we putting in the place of x? C plus 2. That's all that this means. Negative 4 parentheses c plus 2 plus 9. Negative 4c minus 8 plus 9. Like terms together. After you do that distributive property, you just simplify that side. So that's negative 4c plus 1. Not too bad. Number 19 is using the g of x function, which is x squared minus 5. What are we putting in the place of x? A minus 3, right? This one's a little tougher, so I wanted to do it. We're plugging in a minus 3. What does it mean to square something? Times it by itself. So I'm going to write it out as a minus 3 times a minus 3. Most people that miss this problem don't do that. They try to take a shortcut. There are shortcuts to that, but I don't think they help. You can't. No, your calculator can't do that. It can't. It can't manipulate variables. Photomath can, but I advise you don't use that because I can tell when you do your homework with Photomath because you write down the answers the wrong way, like not the way that I teach you how. So I know what's going on with Photomath. So a times a is a squared. A times -3 is -3a. -3 times a is -3a. -3 times -3 is plus 9. And then we still have the -5 there. So it's just distributed property twice. In Algebra 1, you may have had a teacher that called it FOIL method. Maybe, I don't know. I don't call it that when I teach it. I call it distributed property because that's what it is. But it's, you just front term times everything, back term times everything. That's all you got to do. Simplify like terms together. A squared doesn't have any other squared, so that's only one. -3 and -3 is -6a. 9 and -5 is +4. And there we have g of a minus 3. You need to be able to do 20. If you want me to do 20, I will. Because you're probably going to have to do one like that on the practice. You want to go over it? I think it'd be a good idea. Let's finish up. We got time. It's only 2:37. G of 2m plus 1 minus f of 3m minus 7. So we're going to use those same two functions that we used earlier, and we're going to have to do some separate problems here. We're going to have to find g of 2m plus 1, and then we're going to have to find f of 3m minus 7. And get those answers and then subtract them. Okay. So let's do the hard one first, the g of 2m plus 1. So that's going to be 2m plus 1 squared minus 5. That's right. If you want to go ahead and write it that way the first time, that's fine. 2m plus 1, 2m plus 1 minus 5, which is 4m squared plus 4m plus 1. 2m times 2m is 4m squared. 2m times 1 is 2m. 1 times 2m is 2m. 2m plus 2m is 4m. 1 times 1 is 1. I'm just doing that step in my head. That this is 4m squared plus 2m plus 2m plus 1. And then minus 5. And then the 1 minus 5 turns into 4m squared plus 4m minus 4. Now let's go over here and do the work to find f of 3m minus 7. So that's going to be -4 parentheses 3m minus 7 plus 9. Multiply -12m plus 28 plus 9. Negative times negative is positive.
I need to announce a bus change for today, for Tuesday morning, and for Tuesday afternoon. Darla Ritter's bus 084 will be picking up Greg Brasher's bus 193. Again, that's for this afternoon, Tuesday morning, Tuesday afternoon.
Simplify the like terms there. We got -12m plus 37. And here's the tricky part to this one. Believe it or not, those were not the tricky parts. The tricky part is taking that and subtracting it. Minus, and then when I subtract that, I'm going to put in parentheses, -12m plus 37. Because I'm subtracting that entire function, not just part of it. So that's going to be 4m squared plus 4m minus 4 plus 12m minus 37. Notice how I distributed the minus sign to both of those. That's what I did to get that next line. So the blue line came from the blue distribution. Then simplify it, put like terms together from there. 4m squared plus 16m minus 41. And there's our final answer for that one. A lot of work for 20, but still, it's doable. It's not anything just incredibly great. Okay.